Welcome to the Road to Certification Professional Machine Learning Engineer session number 4, week number 4. So before I start talking about the material, there's one thing that someone mentioned in Slack. I think yes, you got your Yenga mentioned in Slack that this the machine learning path had changed. So I'm going to share that screen and I'm going to discuss some of the material get changed. But I just want to say that we're going to stay on course because some of the material is actually the same. I'm going to describe them just right now. I'm going to share my screen to that slide. So this is the updated machine learning engineer learning path. So basically, you go up to number 4, and then the one that we talked about last week was machine learning in the enterprise, and that is replaced by 05, 06, 07, and 08. So if you look at this content, it's actually machine learning up, and basically it talked a lot about the machine learning in the enterprise. It's talking about how to get started and talk about how to use Vertex AI, manage the feature, and it talks about the model evaluation. The only thing that the exception is haven't talked about in the other path, the old path, is that there's no mention of generative AI. So they've including this one, including a 30-minute generative AI content in it. I haven't reviewed those yet, but I would recommend it everybody before you're taking the test. And I believe this is like 8 hours, maybe two and a half days, so that you can actually review all those. Actually, number 9 also. Number 9 is actually, we talked about this machine learning pipeline in the previous session as well. So that's some of the change. I think the other change, maybe I forgot these one. Whether these one has changed or not, but the production machine learning system that we're going to be talking about today is actually moved to less than 12. So anyway, so just keep in mind that before you're taking the test, it's good to just go through them and make sure you understand them. So as far as the getting the voucher why, we're not going to be gauging on these being complete. We're going to be go by the original path. So I'm going to switch my slides again, go back to the other slide. Okay, so this week is number 4. And well, I'd like to thanks again to all the GDG organizers co-hosting for this session. GDG Cloud Boston, Capital Region, San Antonio, Ocala, Tampa Bay, State Coast, Modestos, and Surrey. So this is where we're at this week, week number 4. And we're going to be talking about production machine learning system and computer vision fundamental with Google Cloud. So they actually remove computer vision fundamental with Google Cloud, but I believe it's still very valuable for you to go to them. And like I said, we're going to be gauged on for the voucher. We're going to be gauging on these. So the tracker is actually tracking those, not tracking to the new path. And hang on a second. Okay. So also we're gonna have, like usual, we're gonna have a raffle today. Also, let me just share some information. I'm gonna share the slide first. Sorry, I'm gonna share the form that you can fill out while you're listening for a raffle in the chat. This is the link to the raffle that you can put your name in. So at the end, then they can just go to this. Um, and I'm going to, I have to get the link to the slide. I forgot to get that. Let me get the link to the slide. I'm going to share my screen again. That's the link to the slide. Okay, let me share my screen again. Okay, so you have the link to the raffle, and then you have a link to the slide, and see what else I need to share. I think that's it. So we're gonna start. Bear with me a second. All right. So this was content I mentioned earlier. We're going to be talking about production machine learning system and computer vision fundamental with Google Cloud. So I think most of us are very familiar with this slide. And basically, the machine learning process involves a number of steps, from the ingestions of the data coming in to the system into Google Cloud, to the deployment and continuous monitoring and updating the model. So feature engineering that we talked about is a very crucial step in the process of predicting modeling. It involves transformation of a given feature and with the object of reducing the model error for a given target. So the underlying representation of data is crucial for the learning algorithm to work effectively. The training data used in machine learning can often be enhanced by the extraction of feature from the raw data collected. In most cases, appropriate transformation of data is an essential prerequisite step before model construction. So basically, this is the process we are familiar with. That's what we're going to do. So when you're building a production machine learning system, you have to go through the development of your model through this process. But also, when you're building production learning machine system, you still have to go to very similar process, but architecting how you're actually hosting some of these components. So the production machine learning system have 4 pillars that we touch on a little bit. So the first one is the architecting production machine learning system. And basically, they talked about what an ML system should be able to do, and the component that take the responsibility for the action for those actions. And then we talked about designing an adaptable machine system how change can affect the ML system, and what can be done to mitigate those effects. They also talked about designing high-performance ML system. So they talked about the optimization on the performance of an ML system by choosing the right hardware and remove bottlenecks. And then lastly, they talk about building hybrid ML system. They touch on the technology behind the hybrid system, and that allow enterprise workload to run on the cloud, on the edge using mobile device, or on premises. So we have talked a lot about building the machine learning models, right? So what percent of system code does the machine learning model account for? Would you like to take a guess? So we're saying some say it's 5%, 25%, 50%, 90%, 6%, 5%. You're right. So 5% is the correct, because it's not surprised that the actual percentage of code that to develop the ML model typically account for about 5%, because there's many tasks that you do before besides just training the model, like the data engineering, the feature engineering that we have to do, and then deploying the system and setting up the monitoring of the system. So that's a lot of tasks around building the production ML system. So if you look at this slide, so the machine learning model code, building the model code, is just a tiny bit here, 5%, and then you have all the other tasks that you do that I mentioned earlier around it. And this picture is that I think we have shown a number of times. This is a detailed machine learning processes that typical machine learning development go through. So we're going to touch on those a little bit. So we're going to touch the data extraction, analysis, and preparations. And we're going to touch on the model training, model evaluation, and model validations. And then there's a model deployment, which is on the right-hand side. And then there's a model monitoring. So we monitoring, including monitoring not just the model itself, but also monitoring the performance of the model, as well as monitoring the performance of the system as a running system. So in terms of the data extraction, analysis, and preparations, so we have different set of type of data depending on the problem that we're trying to solve. So we have structured data, unstructured data, and streaming data. So structured data are the typical data coming from either you have a CSV file, the text file, JSON file, XML file that is actually incoming to your system. Unstructured data are those are the images, videos, and text coming from chat session with your peer, your customer, whoever they may be. Streaming data typically come from the real-time IoT devices from the edge. Like for example, transportation vehicle where it has a sensor measuring some environmental information around the vehicle, transportation vehicle, payload, whatever that may be, and then that's got streamed into your system. With the structured data, we can actually import them into datasets into BigQuery. So the reason we want to import them into data set or into BigQuery, so we can use AutoML to do training data set, or we can use BigQuery ML to train a data set. For the unstructured data, we typically store them. Well, typically they say they're stored in Google Cloud storage. For the streaming data, it can be handled using Google Cloud PubSub. For those of you may not know what PubSub yet, PubSub is a managed service where you can actually stream data from the IoT edge device and then to PubSub, and then from PubSub we can subscribe to the into a topic, and we can subscribe to the topic, and then you can receive data from it. So when we're looking at data, we have to understand our data. So we have to use the graphic and basic sample statistic to explore them. So data scientists typically can help in performing some of the data analysis and exploration phase, because the process requires data and statistical skill. And sometimes as an engineer, we don't have that skill. That's why we have to work with the organization, data scientists, together, collaborate with them to help understand the data, so that we also work with them to build the machine learning model. So they can help the team to identify how changes in the distribution of data might be affecting the model. They can look at the output of the model and compare the changes in the distribution of the input into the model and analyze the overall performance of the model. This is data preparations. The last part is data preparation phase is basically include data transformation. Sometimes you have to transform the data into other format, and feature engineering, identify the feature that we actually want to see in the model. So this is the process of changing and converting the format of structure value, so it's transformation into the data that another format that the model can actually interpret. So now we go down to model training. So basically, we kind of study this in the past. We can use AutoML, or we can do custom training using TensorFlow. So basically, we're feeding the data into the algorithm, and then identify which is good value for the feature set, so that you can actually use the data incrementally improve your model prediction ability. So we have to, when we do the training, we want to look at it. We're going to be talking about evaluating the result, the overall prediction result, performing result. So model evaluation, we basically estimated generalization of accuracy of a model on future unseen out of the sample data. So we train with a set of data, but when new data coming into the model, they haven't seen it before. We want understanding how well the model does. So model validation is that we want to evaluate the model against a fixed threshold and alert engineer when the prediction results are in fact satisfactory. One common test to look at the performance by slice. So in this example, the business stakeholder cares strongly about a particular geographical market, is shown here in the green region. So an alert can be set to notify engineer when accuracy at the country begin to skew downward. So the model evaluation and validation component have one responsibility, that is to ensure that the model are good before moving them into a production environment. So we are doing all of this during model development, but we want to make sure we get a good result before we actually move them into production. And after we have gotten a model that we're satisfied with and ready to deploy, and basically we set up the deployments into the production, and then we set up a REST API for external user, those are the client and user, and using the REST API to get the prediction from the model. So, I mean, I actually touched on very high level of all the material in this code. There's lots of material I couldn't cover in 1 hour. So basically, I picked some of the highlights and then we talk about it here. So performance monitoring. Basically, we want to detect there are data skew. There's a data skew is between the input and looking at it. With the input and looking at the output, this is something that the model is doing what we expected. If we identify data skew, and then we have to do something about, maybe we might have some time to retrain the model. And we have to go back to the development environment, making sure that we can retrain the model. So sometimes the input data change could caused by the application change. So the application change, the input data could change, and also business requirement change, and the application got changed, and then that result into the input data change. So that would cause some skews in the performance of the model. That's why we need to make sure we set up some kind of performance monitoring in the system so that we can identify data skew. So this performance monitoring is related to the traffic pattern. So when we're talking about traffic pattern, is that we expose an endpoint for a user using the system. So the traffic pattern is how the user coming into the system. The amount of user coming to the system, and looking at the error rates and looking at the latency of the model, and then looking at the resource utilization of the actual hardware machine itself. So we can set up alert in the ML system itself. So in our case, in this discussion, we mostly focus on Google Cloud. So Google Cloud has a monitoring system allow you to set up monitoring alert of all those items. So when we're architecting a machine learning system for production, so we have some design decisions to make. So for training the model, there are two types of training that you can actually go to. You can do a static training. So we do what we did in the last specialization. We gather our data, we partition it, we train our model, and then we deploy it. So in the dynamic training, we do this repeatedly as more data arrives. So this is like dynamic training in the system itself. So when new data comes in, we're detecting skew, and we have to retrain the model and then test the model, retrain again. I mean, certainly there's trade-off between the static and dynamic. The static training is simpler to build and test, and likely to become stale. But dynamic is harder to build and test, but it will adapt changes easily. There's a question, Rajesh. You asked, I have completed 50% of the lab. Do we need to add our name in any doc after completion of the lab? When you're completing your course, at the end of the course, you will get a badge. So we know that you actually completed the badge. I believe you provided your public profile of the Cloud Skill Boot to us. So that's how we actually find out whether you have completed or not. So, and then we have to consider the design decision for serving. And there's also there's a static serving and dynamic serving. So in architecture, one of the goals is to minimize average latency. So when latency could sometimes it's caused by CPU resource, memory resource, or disk, or the amount of traffic coming in, right? So and just like in operating system where we don't want to have we want to be bottlenecked by slow disk I/O, right? When you have slow disk and then reading from this in application become very slow. So when we're serving the model, we want to be bottlenecked by slow. We don't want to be bottlenecked by the slow device. By slow to design model, and then so solution for serving models is very similar to what we do to optimize our I/O performance. So we use a cache for static serving, and rather than a fast memory. So we could use the lookup table to do that. But for dynamic servings, we have to compute the label on demand, and static serving is just space intensive, resulting in higher storage costs. So when we develop these systems, we have to also considering the cost associated with that too. So in dynamic serving, we have the lower storage cost but higher maintenance and variable latency. And the choice whether to use static or dynamic serving is determined by considering how important latency, storage, and CPU costs are. Chai-Mei, you haven't received your course yet, and the lab credit yet. So I need to check with Roman. Roman is not with us tonight. So if you don't mind, can you put your question into Slack so that I can remember you asked that question, then I can follow up with Roman. I'm just trying to put a note for myself. And also let us know when actually you signed up for the session. Well, Rajat, you haven't shared public profile. You can actually also put that in Slack that I can. We have to update the tracker to include your profile. So now we get to the hybrid system. So in the past few sessions, we assumed that we develop an ML system in the cloud native environment like Vertex AI. So everything we've gone through in the past is like Vertex AI provide the entire environment for you to develop your machine learning model, as well as let you serve the model to the cloud. And we gone through all of the lab. The lab include all the exercise that we have gone through it. So the Vertex AI basically allow us to import the data into the data set and to perform data analysis and preparation. All of that, we've done that. And we then train the model in either model MLs or custom model using TensorFlow. We actually cover all these two areas. After the training is completed and we serve the model to the Vertex AI infrastructure, is there a time when you cannot be fully utilizing the cloud native infrastructure? I would say yes, because perhaps that you cannot move your on-premise data to the cloud, and then you have to use existing system on-premise, or maybe you're running machine learning on the edge or on the device itself. Or maybe the data is being produced by a system that is running on a different cloud, or the model prediction needs to be consumed from another cloud. So those are the area that that in use cases where you have to actually implement a hyper machine learning system. So Kubeflow that we talked about last week is a managed service provided by Google Cloud. Kubeflow is an open source Kubernetes native platform for developing and orchestrating, deploying, and running scalable and portable ML workload. So, I mean, for those of you who may not understand what Kubernetes is basically a serverless architecture. It allows you to run multiple containers, separate container in a contained environment for a typical features that you develop. And so it allows organizations to manage end-to-end orchestration of the ML pipeline. So Kubeflow is very good at creating a pipeline for ML workflow, and then to run the workflow in multiple or hybrid environment, so that it can be easily deployed on-prem or to the edge. Also, Kubeflow simplify component reuse across different workflow, because Kubeflow is a containerized architecture. Kubeflow support visualization, also collaboration in ML workflow as well. So Kubeflow has lots of features that you can utilize to implement the hyper ML system. I'm going to check this chat a little bit. So, yeah, that's right. That's the link to the bad tracker. Thank you, Carol. So there's three criteria when we're architecting and building the hyper machine learning system. We should be considered when the architecting hyper machine learning system for these criteria. Composability is about microservices. It's about putting together many microservices together. So Kubeflow can do all of that. So microservice architecture provides a separation of the concern and independent execution environment for each feature in your overall architecture. It is a misconception that building an ML model takes 95% of the effort. This is the other thing that we have to consider, like the composability, meaning putting all the things together that we can actually distribute. If you want an architecture to support multiple environments or moving it around, we would consider portability. So we're calling that in the machine learning development workflow. We must spend time in all aspects of the machine learning workflow. When you are developing your model using microservices in your development environment, everything is finally running. And what happens next? You get it all running in your development environment. Now, what's next? You would have to work with the DevOps team to deploy it to the production environment. Well, actually, you can't. Before that, you have to create the environment itself, right? The DevOps team needs to understand how to actually create an environment to deploy it. And then you have to ask the question: does your architecture easily repeat in the production environment? So you have gone through your architecture in your development environment. Is it easy to translate it or migrate it to the production environment? So, and then also you have spent a lot of time doing the machine learning model development, developing the configuration, the parameter, and testing all of that. You don't have to repeat the same efforts in the production environment. You just make sure that everything being tested and work, and then you can deploy it in the production environment. And also, I mentioned, you want to be able to create architecture that easily satisfy the DevOps requirement, which is create the same exact environment for development, staging, and production. And for all of us as software engineer or working in the cloud, when we architect the system, we have to think of how do we actually develop a software in an environment locally or in the cloud first, and making sure all of our code is running and maybe bug free, but I'm not sure that's going to be 100% bug free. And then we will deploy our final code, the final beta code, maybe some code we cut it for release, and that got released into a staging environment. The staging environment, the goal is to let our test team, our QA team, have an environment that way they can actually test our software. And after our QA team validate the software, they're satisfied, they are passing all the criteria in our test plan, then we can deploy our software into production environment. So all these three environments, they should be very identical in my mind. So when I architect a system, I make sure that all three environment is identical. And then the final criteria is to consider when you're architecting a system. The final criteria is that may not be the final one. Is consider scalability. How does the system scale? Does it take you have a lot of requests coming in? How many requests that you can process per second? So we need understanding the business requirement on that as well. So we need to architect the system that easily scale. When we're talking about scaling, there's a different way of scaling a system. We can scale it vertically or scaling horizontally. So when we're talking about scaling vertically, we may be increasing the hardware resource like CPU memory or something like that. But when we're talking about scaling horizontally, meaning that we have to add additional system so they can actually serve the same model to the end user. So we can actually distribute the traffic coming into a different system. So that's one of the things that when we're architecting a system, we have to consider all of that. Yes, I agree. pertaining that you mentioned, yes. One thing I failed to mention is that in this cloud environment is very critical. Security is very critical. That we have to implement security in cloud environment, and you can actually get denial of attack into your system, right? So that somebody's sending a lot of traffic into the system. Your system basically cannot handle it, and then nobody else can come in, right? And somebody can penetrate in your system, penetrate your system, and get all of your data from you, right? You don't want that. Uh, I just want to mention that just recently, last month, I found out that my medical data, I think, is got. I got a letter from some company, medical company, saying that my medical data is being compromised. I was like, how could it be? I mean, I know how to design the system that maybe it's not bulletproof, but at least, you know, I put a lot of safety, security, and safeguard into the system so that it's not easy to penetrate, right? So you want to design a system like that so that you don't want the hacker or bad people coming into the system and steal your data. Okay, so we're gonna transition into the next topic. So this computer vision, which is we found out that, yeah, PHI, right? PHI is very key into medical device. I've worked in medical device for 18 years, so for every time we write our software, we have to worry about PHI, PII, and HIPAA, and all of that. It's no fun, but we have to do it. Privacy is number one goal. Well, anyway, so computer vision fundamental on the Google Cloud. So what is computer vision? Computer vision is the ability for a computer to understand and analyze digital content in the same way as humans do. But I think they're getting there, but it's not as like, complete human yet. This includes tasks such as recognizing objects and face, which the computer can do, and reading text and understanding content of the text of an image or videos. Also, the generative AI can detect sentiments. It can read some PDF and they actually analyze the PDF and they can determine the sentiment. So some of the use cases in computer vision. So I don't know, you've seen self-driving cars, right? If you go to San Francisco, you will be amazed that this. It was actually I was amazed. I saw Vimo. I think Roman and I actually saw it. We went out there back in May. There's a Waymo. I think Google. I think Google somebody owns that. Waymo is a driverless self-driving car. It's like so incredible that I saw people just got in the back. There's no driver in the front, and they drive on the street like normal driver. It can yield, and somebody across the street they can yield the pedestrian. It's like there's a lot of technology, computer vision involved in that, right? The other thing that I'm very passionate about is robotics, right? So I personally teach high school. I actually mentor high school to do high school robotics, and a lot of time we use a computer vision. We have a camera that we actually recognize and a game object that we need to recognize where the placement of the game object is. And based on the placement of the game object, we have to program the robot to do certain things, right? So that's computer vision. That's the object detections, right? The other use case is the coastal classifier. So this is, I've seen, I Googled and I've seen a lot of aerial video. They capture the coastline, and some scientists and somebody may want to, study about that. So can we train the computer understanding the changes in the environment? Yes, I think we can do that, right? So in this, there's APIs associated with all of it I just mentioned earlier. Depending on your app requirement, you may consider using these API for a use case. So this API designed so that you can actually use the API for your app. So Document AI is a managed service that allow enterprise to turn their unstructured content into a structured data. So you have a whole bunch of, see that on the left side in this picture is a whole bunch of document, either PDF, Word document, whatever they may be, Google Doc, and other formatted document. So Document AI can parse and reading to all of them. But when we do it ourselves as a human, it's going to take a lot of time, right? So Document AI utilizes machine learning algorithms like OCR, image recognition, natural language processing, entity extraction, and machine translation and data loss prevention. So Document AI is an end-to-end cloud-based platform for document processing. Not only that it can read document, but understand the spatial structure of the document. And then Vision AI is another managed service in Google Cloud Platform. So this API provides computer vision capability so that we can perform analysis on completely unstructured data like image and video, and we can use it to detect objects and read handwriting. You can read image-related metadata. It is compatible with many cloud services from Google. Video Intelligence API can also analyze video content moderation, and recommendation, media archive, and contextual ad. There are only a few of the Google. These are only a few of Google offerings. So I don't think I have time. I was going to show you a demo of what the Vision AI is. So we're getting 8:47, so I got to finish. I think I only have a couple of minutes to finish. I want to allocate maybe like 10 minutes to do the final, the raffle. I'm going to keep going for a few more minutes. So there's computer vision training. So we can train it with AutoML. We can train it with TensorFlow. So Vertex AI actually provides the infrastructure for us to do model trainings, right? As we know that Vertex AI is a great platform for developing machine learning model and deployment. So AutoML is we all know that AutoML is a no-code managed service for AI model development, and AutoML support image, video, text, and tabular data. So I have some note you can just read to it. And then the training workflow for training using AutoML model is the same as we have talked about, right? And then if we want to use TensorFlow is a little tedious. You have to write code and actually set up the sequential model, importing your data first and setting the sequential model, and then set up whether you have a single layer or multi-layer or neural network. So you can do all of that with TensorFlow. TensorFlow is actually a powerful API for custom training. So I mentioned that the linear model for image classification. So image classification is like identifying the class and object you want to identify. For example, you want to identify whether the image is a cat or a dog or things like that. But it has only one input and one output for the linear model. It doesn't have any other layers. You can work with the binary data or multi-class. And then I'm going to go a little bit quicker. So here, so neural network, I mentioned earlier, so the single linear model is single layer, but with neural network, and you can create another hidden layer. So hidden layer have all the neurons. So the input feature is neuron connected. They are interconnected to each other. You have the input layer and the hidden layers and output layer. And some of these, the neuron has a weight that you associate with it and the bias associated with it. So this is only used for additional hidden layers. Only used when the linear layer does not providing the result that you actually want. So you want to improve the prediction result, then you have to add additional hidden layer to your model. The convolution network, this one is for, I mentioned my the high school robotic team, we have to do an object detection. So we actually using a convolution network to build the machine learning model that we use to detecting an object in the field. So convolution neural networks are very similar to the neural network that we talked about previously. They just made up a neuron that learnable weight and biases, but not all the neurons connected to each other like we said before. Some group them together and connected to the output, and some does not. But they actually include the width and height and depth. I mentioned CNNs can do image analysis tasks like classification, object detection, and segmentation. There's many practical use cases for CNN, and I will mention one of them. So, yes, convolution network. So I don't understand. I did not hear it well. It's a very it has a different layer. The different hidden layer do very differently so than the neural network itself. So not, like I mentioned, not all the neurons connected to each other. I think this is the last slide that I have, I think. So when we are doing machine learning, we have to deal with, when we're dealing with image data, the image data usually come in unstructured form, typically in pixels, right? A lot of image data is stored in either PNG or JPEG. This is an efficient way to store an image data for large-scale ML model because most of the model training would be waiting for the image to be read. And that's why we should be using a more efficient data format for the model training, like TensorFlow record. So actually, TensorFlow provide the API where you can actually TF data and the other API that allow you to TF data out to your data set, but there's the other API allow you to the Kara API actually allow you to read the image data into TensorFlow and convert it to something called a TensorFlow record, the TF record. This is TensorFlow record. And TensorFlow record is stored as a vector format, so three-dimensional vector format. This is the reason they're stored in the vector format because all of the machine learning algorithms are using linear algebra. Linear algebra, you do matrix multiplication, and all of that, and that's why it's more relevant to this format, more relevant to training the model. So we don't, because we're converting the image, the pixel data into a vector. Okay, it's a diff link to the bad tracker, not sure sign up form. Okay, this is the app tracker form. This is not the sign up form. This is a app, the tracker, right? So if you click on it, and just bring up the tracker app. Okay. Okay, I'm not. I don't. I think I'm done. So I don't. I'm not going to go to this. Some a couple of sample review question. I'm going to go. You got any question? Please ask in the chat. I'm going to go look at the form that you filled out for the raffle. Yeah, we recorded the session, but we have to post it in YouTube. Okay, I'm gonna go. I just want to make sure I have 34 people respond to the raffle, so I'm gonna get. I'm gonna copy the name. I hope we can do this. I haven't done this. Usually Roman do this for me. Oh, Chanda, you don't see your name. I have to put it. Can you please put a reminder in our Slack so that I can have Roman check for you? I don't have access to the app itself, so I'm going to ask Roman to check that for you. Okay, I'm going to stop sharing this. I don't know Linda's here tonight. I think probably not. I'm looking. You're welcome. Thank you. Thank you for coming. Let me see. Wish me luck. This is the first time I use that. The wheel of names. Okay, let me just put. Okay, okay. I'm not going to spin. So we're going to raffle 2 items out tonight. So let's see what item we want to raffle. Okay, so we have 4 items that we can actually raffle 2 items out. Would you like t-shirts, a socks, cap, or a mug? Just can you tell me how hat? Okay, cool. So we're gonna do the hat first, right? I'm gonna share my screen. Real name. Okay, let's see. How do I run this thing? Control Enter. Huh? Oh, click to spin. Okay. So okay, this is for the hat, and then we can do the mug. Hey. Okay, Johnson. Excuse me. Jointing. Congratulations. So let me put your name down so I know that this is hat. I have your email. We're going to contact you, get your information. And we can order the hat and send it to you. Congrats again. Going to remove you out. I'm going to spin again. This is for the mug. Let's say Philip Wu. Congrats. Congratulations. So this is Muck. Okay. I would like to take a pictures, but I don't have my photographer here tonight. Let me see if I can. I'm not gonna do the hand. If somebody, if you guys can share your video so that we can just do a screenshot. All right. Let's do the hands again, right? I don't know. GDG. All right. Okay, I'm gonna do a screenshot. So I'm gonna say, okay, ready? 1, 2, 3. Smile. Okay, I got one. I'm gonna do another one. Okay, ready? 1, 2, 3. Okay, thanks a lot. Thanks a lot for coming tonight. And we'll see you. So next Wednesday is going to be a office hour session. So we're going to be discussing, reviewing some of the questions. So last week we actually had women share some of the questions they found on, I don't know where they found it, but anyways, an interesting question. So I encourage you to actually attend those sessions. It's going to be very helpful for your exam. All right, good night and see you next week.
Thank you, Kevin. Have a good night.
Thank you.
Thank you.